these things. Okay. So that's step one. So what we're going to do is to illustrate the principles here. We're going to have main, instead of just creating right now main includes a population of what? Who can tell me? Main includes a population of persons. That's what we had dragged in there before. So we're instead going to get it to, and I'll just to lower confusion, I'll close others here. There we go. So this is a population of persons right now. Okay. If you look at this, we had dragged persons. You see, it's a population of person. Okay. We're going to instead make a population of cities, and each city is going to contain persons. Okay. And population of cities is going to be in a distance-based network. Population of persons within a city is going to be scale-free. So we should see something like this. And so I'd like you, as a space-saving measure, I'd like you to, so we get this ability for people to automatically be connected with nice lines and all that sort of stuff, that thing we did on the first day or two. I'd like you to right-click on person, and we're going to make a copy of that agent. We're going to call it a city agent. So right-click on it, copy, and then we're going to do click on the project name and do paste. Okay, paste. Boom. Now we have person and person one. Okay. And I'd like you to rename person one as city. Okay. Person one is called city. Boom. Okay, so now we have two types of agents. One is called city, one is called person. And we're going to be using both of them. Okay. Okay, so if we want this to be a hierarchical model, first of all, let's think about main. How will main be different if we want this to be hierarchical? Anyone want to advance a guess? Well, main is no longer going to keep track of just people. It's going to keep track of cities. Cities, the highest level of that hierarchy, okay? So we're going to open main, click on population, and delete it. So you can do it a couple of ways. You can press the delete button, or you could right-click on it and do delete. And you're going to delete it. Gone. Boom. Okay? So we just deleted it in main. We delete it because we're gonna replace it with a population of cities. Now, what I'm gonna do is now we're gonna drag city over to here. Well, how are we gonna create a population of cities? You tell me. Drag city over here. So that's gonna create a population of cities. So let's call this cities. Okay. And so we're calling it cities here, okay? And we're going to need to do what? If we want this to be associated with a layout, what do we have to associate with? We have to associate with I didn't hear that? Okay, well, it's with an environment that lays it out. It is composed of a bunch of agents, but we have to tell them how to be arranged, and that's what the environment says. Okay? Okay. So environment. So these cities are associated with an environment. We're going to make it replicated, and we're going to build 10 cities. We're going to have 10 cities here. Okay? We could do more, obviously. But okay? 10 cities. We could change that later. Okay, so 10 cities are going to be here. And now I'd like to go to the Advanced tab. Well, okay, so the environment, we're going to want a distance-based network. Where do we set that? In the environment. Thank you. Thank you. So we're going to click on the environment, and we're going to impose a distance-based network with a connection threshold of 250. okay? I've artfully chosen that, so it's just long enough to connect some of the cities. Okay, so where do I specify connection thresholds? Can anyone tell me? For the distance-based network? Well, remember, depending on the network type, different of these things below will be enabled. A distance-based network lets you specify connection range. So that's where you want to be, to specify connection range of 250. Who needs a TA? There's a rump of TAs here. Well, sort of like a rump parliament. And so there's a sort of residual. It's not to suggest like dregs of TAs or something like that, but it's sort of there's some remaining set of TAs is what I meant to imply. Nothing derogatory.
So if I had a collection in my main class and I wanted to take a small subset of that, would I go collection that one?
That's a fine question. You can direct that to the mothership. Okay, so here we have an environment. We set the environment's connection range for the network to be 250. We made sure that it's a distance-based network. Okay. Now I'd like you to double-click on city, and within city, so we're going to double-click on city. Here's our city, and tell me what to fix up. What do I have to change here? Anyone? Is the city going to have living and dead? No, probably not. So first of all, let's get rid of the state chart. That's not going to apply at a city level. But what's another salient difference? The city is going to have what in it? A city is almost defined as being composed of people. There need to be people in the city. So how do we create a population? Remember, this is an agent, right? That's why it's got the Da Vincian logo there. So how are we going to create a population of people? Okay, I saw the hand sign, and Maria is correct. So we just drag it over, and we say population. Okay. Okay, so it's going to be population of people. Now, tell me how to fix this up so that this population can be situated in space, and so that there's some number of people in here. Is this a single person that lives in the city? No, it's a population. So what do I have to do to make it more than one person? Replicate it. I have to replicate it, and I'm going to ask you to use a draw from a distribution here. Say it's uniform discrete distribution between 10 and 200. We should really put this in parameters, but for now we'll just put it here. Okay. Okay. So here we have city, whose initial number of objects. You know, I don't like this at all. I really don't like this. I don't like putting that there. Instead, I want to have the city's population be set by what? By a parameter. So how would I have the city's population set by a parameter? Folks? Okay, drag a parameter in here and call it something like city population or so city population size, something like that. And I'll make it is this a double? Is it a Boolean? Is it a color? An int, that's right. And then I'll have, what will I do for the replication? What will I put here? City population size. Okay? Now this is more flexible because it allows me, for the population of cities, to then specify from what distribution these are drawn. It doesn't hard code it right down here. Instead, who creates cities? Who in this model is going to create cities? Who's going to maintain the population of cities? Name. And therefore, that population in Maine is going to be able to say what distribution from which to draw this, which is more flexible, okay, than just hard coding. Okay, so we have population size there. That's the parameter here, okay? Okay, so how do we want to have the people within the city be arranged in space? How do we do that? What do we need to do to have them be arranged in space? Something to take care of their spatial components. We need a environment. We drag in an environment, and we can call it city environment. In Java, that won't actually. We could have left it name environment. It wouldn't have clashed with the other one. They're in so-called different namespaces. They don't see each other, but we'll call it city environment for good measure. And then what do we have to do? So we've created this environment. Okay, that's good. And I'd like to go set it so it's a scale-free network. And I'd like to set it so it has a width of 75, the spatial area, and a height of 75. Where do I do that in environment? So in environment, where do I set like the network type? Advanced properties. Advanced, and for width I set 75, and for height I set 75. Okay, and I'll have a network type of scale free, and with scale free I'll leave it as the default parameter setting down there. Okay, at the bottom. Okay. So this is good. Pardon me. I'm just going to for a second. That's fine. Okay. So how do I make it so that the population is set up by that environment? What do I need to do? What's the final step? Sorry? Yeah, I need to, in the environment, I need to have it referred to the city environment, right? For the environment for the population. So it has to be maintained by this environment. So I have to say its environment for this population is the city environment, particularly. Okay? Does that make sense? Okay, who needs a TA? Okay, I won't use that term again. Well, because you seem to react adversely to it. Yeah, no, it's good. Okay, great. So let's right-click on simulation and run it. And it's giving me grief. Okay, so oh, look at that. It's giving me trouble. Why isn't that being shown in the problems window? Oh, here it is. There's the problems window. Okay, look at the problem it's saying. What is it saying here? It doesn't know. So I just double-clicked on this. It doesn't know what get main is for a person. Okay? So what's the issue there, folks? It's saying it doesn't know where get main is. So what do I need to do to fix it up? Person is saying, I don't know where to get my main anymore to get the mortality rate. So what do I need to do to fix that up? It says, I don't know where to find main to get the overall mortality rate. Where does mortality rate live? It lives up in Maine. So how am I going to get to Maine? I have to go to city first, and from city get its main. Okay, so I do this dot get city, and then I can go to get main to get the mortality. Okay, and you'll notice it's the same thing just below here. To remove me from, excuse me, no, that's not true. To remove me from the population, whose population will the person be removed from now? From whose population will they be removed? From the city. So we have to do get city here, remove population, okay? So basically this person has to be removed from the city, okay? And you'll notice it's still giving one one trouble, this thing, the final thing is there's a data set in Maine which is saying that it can't, we had set up a data set in Maine earlier. I'm going to get rid of this because it was just, I think it was just for an example. So a data set in Maine that was causing us trouble. So ladies and gentlemen, what did I just do here? What did we do, broadly speaking? We copied person. We renamed it city. We then fixed it up by giving it a population, giving it a parameter for city population size, giving it an environment. This population, its location was given by the city environment, as was its network type. Its network type is scale free. We then went to run the model and we found we couldn't because it was giving trouble. Person in particular didn't know how to undergo mortality here because they needed to get their mortality rate, and it had been located in Maine. So first we had to get to the city, and then from there to get Maine. And similarly, we had to delegate to the city to remove us from the population. That was because the state chart was here. Okay. In the new version of AnyLogic, you could just say Maine dot mortality rate. It'll know how to get to Maine because it's hierarchical. Okay. So those were our components here that we needed to use. There's a parameter variations experiment which is in here, which I don't plan to use, so I'm just going to get rid of that as well. Okay, so I think we should be able to run the model now if we don't have that parameter variation experiment. So we should be able to run it, and we should see something like this. Ooh, look at that. Okay. You'll notice there's now two levels of this hierarchy, cities and Maine. But you'll notice it's saying the population of city 0 is empty. Population of city 1 is empty as well. Why are they empty? What have we forgotten to do? Well, there's still one thing we have to do. We have to set the population of cities. So if you go to Maine, the population of successive cities, go to Maine and go to cities, we have to set an expression for population size. So we're going to set it, so this is in Maine, in the cities collection, we're going to set it to draw from a uniform discrete distribution between, and I think I had it earlier here, it's between 20 and 200, okay? So these are small villages. Okay, so that was in cities in Maine. We had to set what their city population size is, okay? So let me put that into the slides for future reference as well. Okay, there we go. And now we should be able to run this, okay? And we should see something like this. What are these clusters? What do you think those clusters are? Okay, so here we have city 1, or the first city, city 2, city 3, city 4, city 5, city 6, city 7, city 8. Oh, look at that. There's 10 of them, 0 through 9. So these are cities, and you see the population located within that city. So we have a hierarchical model now. We have an overall environment. We have cities, and then we have populations within the city, okay? And we have these population members changing over time in terms of their mortality status within a given city. So if we go up to the top level, we could run this thing forward, and we'll see the population evolving. Well, it shrunk by the end because of mortality. We could run it out again over time on a slower time scale, and what you'll see is that the people are changing, specifically people are dying over time in each of these cities, okay? So what we've done is to create a hierarchical model. How did we do that? within Maine, we had a population of cities. Within city, we had a population of people. And each person could evolve then. When a person needed to figure out their mortality rate, they needed to ask city and not ask Maine so that they could get the mortality rate. And when a person died, we had to remove them from the population of the city. Okay? These cities, you'll notice, are ensconced in a different network structure. The cities are ensconced in a network that's distance-based. Within each city, we have a population whose network type is dictated by the city environment and is instead scale-free. Okay? So this, ladies and gentlemen, is an example hierarchical model. If we wanted to, it would be a fairly ready task to create neighborhoods. Right? We could create neighborhoods within a city. Then it would be a city would have a population of neighborhoods, and a neighborhood would have a population of people. Yes, Kurt.
Did you connect agents with the different cities to each other?
No. Not in this form.
Skype doesn't exist in this model.
So that's a great question. It's a dynamite question. So right now, the city environments, each city has its own environment and their solitudes. And we could have people, and in fact, there's another model you'll find me building online of this sort, where people functionally move from one city to the other. But what actually happens is they dissolve in the original city and they're recreated in the new city. AnyLogic 7 allows you to directly bring people over. But even so, you're not directly having connections between those cities. How would you put that together? If you wanted connections between cities, what would you do? Jared had the right idea. Jared's model. What could you do?
Connect them to each city.
So basically what you could have is one population of people, one population of city, and each person could be associated with a city. But they're not only located within that city. They're actually located in a broader environment, which could include connections to other people. So they're in a global environment in Maine, but they're associated with a city, and they could change that association over time. The city is just a parameter for them. That parameter could modify over time. And that would allow them to have connections to anyone. You would probably want to write code so that they have more connections to people nearby them. Something along those lines. So maybe the chance would be, 80% that'll be connected to someone else in the same city, and 20% is a connection elsewhere. And it would be straightforward to do that. But that would not be a strict hierarchical model like we've seen. Does that make sense? Yeah. So strengths and limitations. Good. Any other questions about this right now? Okay. Okay. So that was a little model. Took about half an hour as expected. So, so this is a hierarchical city population model.